Okay, so hopefully this is recording right now. So, all right. So we're going to start with kinematics. So from what I've heard, you guys are talking about kinematics, and some of you guys are having discrepancy over it. So I'm here to clarify. So, in order to use kinematics, we have to have two things. The first thing we have to have is constant acceleration. Now, acceleration is basically the difference in velocity over the difference in time. When I say difference, I meant like change in, it's interchangeable, like change in time, change in velocity, or difference in velocity over difference in time, whatever the case is. Acceleration is basically based off of this notation right here, right? And this is basically what acceleration is represented. It is the slope of the velocity versus time graph. Kind of like how velocity is the slope of the position versus time graph, right? So we need to have this straight line in order to have, or to be able to use kinematics. Because there's another factor in using kinematics, is this idea of having it in one dimension. Now, what do I mean by one dimension? Basically, it can't be a complex motion where the car, like in this, let's say in this case, the car is going up, down, left, right, circle around, like all that stuff. No, 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 no. The car, when using kinematics, can only go right, left, up, down, sideways, sideways. You can see here that there is a polar opposite with each other direction, right? If I go right, then there has to be a negative right, which is basically left, right? If I go up, there has to be a negative version of up, which is down. You can see here that there's only an up. I'm focusing on a very one-dimensional direction, right? And after verifying that it is a constant acceleration and that you're dealing with one-dimensional motion, you can now use kinematic equations. Now, kinematic equations are to be used to find certain informations, right? So like in this case, we can find numerous information such as the Vx, the Vxo, the Ax, and the At. Now, the Vx is, again, I want to be very clear. You don't need to add the subscripts in the x, but you do have to know what these big letters such as like V, A, and T's meant. So I'm going to basically narrate the equations. The final velocity of the object equals to the initial velocity of the object, right? The object speed at which it starts with, plus the product, when you have two numbers multiplied together, of acceleration, right? And time. Time is as in the duration of time, right? Not like a specific time, but like a duration of time, very much. And that's the first kinematic. Now the second kinematics is this, right? Now I'm not gonna go over what this means, right? Because what this graph is saying is that this equation, displacement is basically the area under the curve, is basically boiled down to this representation right here, where you have the triangle and the rectangle, and some smart people like Isaac Newton and all your crazy 17th or 18th physics, 17th 18th century physicians managed to figure out this equation right here, which is basically shows us the displacement of an object, right? Which equals to, and you can see the here that there's no displacement. What happened was some person just basically, instead of writing a displacement, they just write it as this, and of course they just add the initial position to the outside. But for just the idea behind it, it is basically the displacement would equal to the product of velocity, initial velocity, times time, right? That's time as in like time duration, not again a specific point in time, but time duration, plus 1/2 times acceleration time duration squared, right? And that's based off of, again, this idea of displacement on the velocity versus time graph. And finally, the third equation would be this equation right here. Vx squared, the final position, the final velocity squared equals to the final, the initial velocity squared plus 2 times the acceleration times the displacement, right? And you can also see that there are some variables that some of these kinematics does not show, right, or does not include. For example, in the first equation, uh, it doesn't show any position or displacement, right? There's no x in here, well, besides the subscript, but like actual main x's, like in kinematic equations too, right? And what that basically tells us is that, if a problem gives us, positions or displacement values, then we're not going to choose number one, right? And the same concept applies to the second equation, right? You can see here that there's no final velocity, right? So if the question ever asks us to find the final velocity of an object, we can't use this equation because there's no final velocity to solve for, right? And yet again, the same weakness applies to the third equations. If we want to figure out the time duration, right, of the object, we can't because again, there's no time values or there's no time variables in this kinematic equation. But you can see here that with these three kinematics at our disposal, we can solve for literally any one-dimensional motions with constant accelerations, right? Because of the of the ground that all three of these equations cover, right? They made sure that all of the necessary information you have at your disposal can be substituted into either one of these three kinematic equations, right? So then we move on. Hopefully I have, oh crap. Hopefully I have the thing on there. There they go. So we are going to move on to kinematic equations, right? So, of course, a car is traveling to the right with a speed of 29 miles per second, or meters per second. When a driver slams on the accelerator to pass a truck, with the car accelerating, the car passes the truck in 100 meters and reaches a speed of that 34 meters per second. Okay, so, and the question is asking us what is the speed or what is the acceleration. Now, I'm going to say this right now. When you're tackling a kinematic problem, what you want to do is you want to write down all of these stuff, right? Acceleration, right? A, t, time, velocity initial, vi subscript, v final, vf subscript. And the subscript is basically like a tiny letter that's next to it. It's kind of like the x that I showed you in the PowerPoint, like this x right here with the, that's a subscript. Moving on, and then finally we have displacement, which is basically the change in x, right? Change in position. So with all of that written down, what we want to do is we want to see what we have at our disposal, what is given in the problem, right? So the car is traveling at a speed of 29 meters per second to the right, right? When the driver slams the accelerator, right? So what that tells me is that before he slams the accelerator, his speed is 29 meters per second. Now, we're talking about velocity, right? So the velocity would be positive 29 meters per second. And that is the initial velocity, right? The final velocity after he accelerated is, it says right here, which is a speed of 34 meters per second, right? Again, be mindful of the units. In this case, it's a positive, so we're good there. And we have a displacement of 110 meters, right? Cool. Now, what we're looking for is the acceleration, right? What is the value of the acceleration? Well, we are given, let me see here. We are given, don't mind my dog. We are given the final velocity, right? The final velocity, the initial velocity, we don't know the acceleration, but we are given the displacement, right? So from out of these three equations, which one do we want to use? Well, obviously not number one. There's no displacement. Number two, well, there's no final velocity. So we're gonna have to use number three, which has actually all four velocity, all four what's it called, variables that we need. Right? So velocity final squared would equal to velocity initial squared plus 2 times the acceleration times the displacement, right? So I want you guys to, I don't want you guys to substitute right now. No, no, no. I want you guys to practice trying to solve for A, right? I want you guys to get A equals to something without plugging anything in. Because the reason why is that the AP test wants you guys to focus on the idea of isolating these equations, right? Isolating these certain variables and then plug in the numbers in, right? So, to solve it algebraically, what we want to do is we want to get A alone, right? So what I did was I subtracted the initial velocity from both sides, right? And that leaves us with the um, final velocity squared minus initial velocity squared equals to 2 times the acceleration times displacement, right? Next, what we do is we divide it by 2 displacement, right? That's how we get x, a alone. So basically our acceleration is vx, our final velocity, squared minus vxo, our initial velocity, squared, over 2 times displacement. Now that we got the formula down, then you can substitute, right? So vx, our initial velocity, would be 29 squared minus 34. 34. Wait, sorry, I'm trying to. Oh no, I've written that wrong. Yeah, even me, like it's really it's pretty hard to make sure that it's not screwed up. Okay, so 34 squared, my bad, minus 29 squared over 2 times displacement, which is 110. Now, again, the reason why the displacement is 1110 and not like 100 and a negative 110 is because the car was going to the right. So that means that any distance covered is referring to the right, which is basically a positive. So with that in mind, we basically use our calculated. So 29 squared, okay, and divided by 2 times 110. So our acceleration is approximately, and it says do it to the nearest two significant digits. So 1.4 meters per second squared. Right? 1.4 meters per second squared. And there you go, right? So again, it's this idea of basically just reading the problems and understanding what is given, what are you trying to solve for, and how are you going to algebraically solve for that, right? Because what we had in the previous problem, right? We have basically displacement, final velocity, initial velocity, but we're solving for acceleration, right? Okay, but from there we understand that these four variables that is discussed in the problem matches with one of the three kinematic equations. And in the case that it doesn't, right? Let's say that you have a variable or a variable collection, right? Your knowns, where when you analyze your knowns, it doesn't match with one of the kinematic equations. That basically means that you would have to find one of the variables on your own, and then from there you would substitute that in, and that's basically it. So, look, I know that kinematics, although it's an easy topic to teach, right, it requires a lot of practice. Right? It's not like a very difficult thing, but for beginners like you guys, it's really hard to fall behind in physics if you don't get this kinematic stuff down, right? Because truth be told, kinematics is by far the easiest thing to do in unit one and in physics in general. Like, if of all the equations, you're gonna be so happy to see these equations. more than the other equation that you might discuss in previous or other units that you'll be covering this year. But I hope that you guys are going to do well on that exam. And I also have this question. I was thinking of having this live discussion or live practice AP Physics 1 session, maybe on like YouTube or Instagram, where you can just tune in and just see how I or Abel, me or Abel actually can tackle these problems and show you guys how our minds think and how to ingrain this AP Physics 1, test taking strategies that we incorporate as, time goes on and on and on, right? And how, of course, how we're developing the skills of just analyzing, what is given to us and how we're going to achieve that, right? But until then, this is a session. I don't know what session this is, but this is basically kinematics. I hope you guys enjoy this. I think after kinematics, we're going to discuss about free fall, which is not really like in the far realm. It actually ties in with kinematics, but yes, we're going to talk about free fall and maybe meander towards relative motions. And of course, after that, we're going to talk about projectile. But I want to scare you guys. What I want you guys to do is just focus on kinematics and just practicing this idea of doing this, doing the problems, understanding the problem, understanding what the problem is asking you for. And yeah, that's basically it.